Roadkill Garage, reviving the Crusher Impala from the dead.
It's back and it's on the track.
498 cubic inches, baby. The Crusher Impala here has been through the ringer on Roadkill. We initially put that blown big block in it for an episode with the guys from Mighty Car Mods, and yes, it had a one-legger and no alternator and all this other kind of stuff. Subsequently, we've had the thing on Roadkill. Remember the episode where we did the shootout against the Rotson? And this thing actually did little wheelies off the line. It was amazing. I think it ran 1170 in the quarter mile. And then we had the thing on Roadkill Garage where we did the gnarliest ever burnouts for distance with no brake drag, just full-on power. Now, here's the really bad news about it. All the Roadkill cars, once we're done with episodes, they end up going into long-term storage. And our old storage lot was outside. And we had the engine on this thing covered, but the cover dried out or blew off or who knows what. But the big block got all full of water.
Junk.
Wow, look at that.
Pitted.
I can virtually assure you that this is going to be good.
Well, that's not going to happen with this car anymore. It's actually my personal car. We're going to fix it up in this episode, rebuild the engine, get it in the car, do hella burnouts, get it to the drag strip, and then it will be stored indoors. Hey, Steve, you realize that this is going to be an actual, like, reality show deadline situation as we put the Impala together?
It is, because we've got to make it to the track in this thing.
Exactly.
If we don't, man, we don't have an episode.
But he's right. The thing is, we got the block at the machine shop right now, and if it doesn't come back tomorrow morning, we're screwed. Because basically, we got to prep everything today. We have Tuesday, Wednesday to build the engine, Thursday to install it, and Friday to be at the drag strip.
Right.
Can you handle it?
Oh, man, we've got this.
I am degreasing. Steve's going to go inside and clean up some of the engine parts that we took apart the last time you saw the Impala.
So I gave Freiberger the really dirty job of cleaning the engine compartment on the Crusher Impala. Meanwhile, I'm going to be in here cleaning up all the parts. In theory, I'm going to have stuff like the crankshaft, the oil pan, the front cover, the water pump, and I want to fill in the manufacturer's logo here at the end of the cylinder head, and then I'll paint them red, and we'll have just the look we're after.
The paint on the block is dry enough. Dulcich is working on pounding out a dent in my oil pan and painting more stuff. I'm going to start gapping the rings. What that means is putting the piston ring in the cylinder and setting the gap between the ends of the ring itself. You have to have a gap there because as the engine gets hotter, the ring expands and this part gets tighter and tighter, and you don't want them to touch because if those two ends touch, the whole ring will buckle and usually break the piston. So for this supercharged big block with a 4.32-inch bore, we're going to put the ring end gap way bigger than we used to in the old days. We're going to do 32 thousandths on the top ring and 35 thousandths on the second ring. Now, to do that, what I'm going to do is press the ring in the bore just like that, then rotate it in, and then I need to make it square in the bore, and since my SRP piston has a flat top on it, I can use the piston itself to push this down and get it perfectly square, just like that. And then I'm gonna take your regular old feeler gauge, and I've got my 32 thousandths blade right there, and I'm gonna stick that blade in between the ends of the piston ring. Now this one is still way too tight, so I'm gonna have to grind on it some more. In the old days, we would go in there with like a diamond file and sit here and hand file the ends of the rings until we got it just right. And that was safer because you'd only take a little bit at a time. However, with this total seal machine, you can actually go hog wild and take off a lot of material, so you gotta be careful. But this thing is the trick, easy way to get ring end gapping done quickly. What I'm gonna do is stick the ring in this fixture, and it's got a stop right here, which I have set to make sure that the end gap is perfectly parallel once it goes in the cylinder. And this stop is gonna set where the ring falls in there, so I can do the same thing each time and tighten her down, move the stop away, and then as I turn on this grinding wheel, I can then move the ring in and out to grind it a little bit at a time to make sure that it's perfectly parallel in the gap, and I'll just keep going back and forth between the grinder and the bore, checking and checking and checking until I get that ring end gap just perfect, at which point I need to go in with a hand file and deburr the end of the ring. So since you can see that I am going to do this 16 times, it's gonna take a while.
Here's something you'll find once in a while, especially when you're reusing parts off an engine that has been in the car before. This oil pan has got a pretty big dent right here. I don't know what it hit. I really don't want to leave it like that, even though it'll probably run just fine. I'm going to hammer that out. I'm not going to use anything special, just a big maul and this piece of 2x4, and I'll just give it a few whacks with these tools, and I'll get it just about perfect. I'm gonna have to hit it from the front a little bit, but that's almost there.
I realize one of the things that's gonna happen to you while you're gapping rings is you're gonna lose track of what's the top ring and what's the second ring on the piston. So if that happens, there's a good way to know which is which. The manufacturer will put a little dot embossed into the ring to tell you which way is up. Second, you look at the cross profile right here of the end of the piston ring. And as you look in that shape, here's what you're gonna see. On the top ring, you've got the outside here that touches the cylinder wall, and then it goes in and it has a bevel right there. So that's your top ring as you're looking through the cross section. The bottom one is exactly the opposite of that. It's got the bevel there on the bottom side. Now, what these do is as the piston is moving upward on the compression stroke, the air is going to come past the little gap in the piston, come in here and act on this surface and here, of course, which is going to help move this thing out and seal it up towards the cylinder wall. The second ring is designed to do the same thing on the downstroke. It has to seal as it's coming down on the intake stroke also, and so in that case, it'll act on this bevel that way and end up pushing it up towards the cylinder wall. There we go. Great. Steve got tired of watching paint dry, so he's helping me set the main bearing clearance. Here's what's going on. I've got all the bearings in the block. We've installed and torqued these 3 caps. Steve went over to the crankshaft and measured the crankshaft main journals with a micrometer. We very, very lightly and carefully locked it into the vise right here, and then took the dial bore gauge and set the dial bore gauge to 0 at exactly the size of the main bearing on the crank, or the main journal on the crankshaft. So now, once we put the dial bore gauge in the bearing right here, it will tell us how much clearance there is, which is basically the difference between the size of the journal on the crankshaft and the size of the diameter of the bearing, right?
Right.
I'm gonna write on the caps what we've got on each one.
This is about 2.3.
3, that one's tight. So that's 23 ten-thousandths of an inch. It's 0.0023.
This one is about 2.8.
Okay.
2.8.
2.8. I'm okay with 28 and 28.
Yeah, that's fine.
This has a one-piece rear main seal, and so we slid the rear main seal over the crankshaft before Steve dropped it in. Okay, main caps are going on. Remember, the main caps actually go in order. They are stamped from the factory, numbered 1 through 5, and they also have a forward and a back, so pay attention to that. If they're not, see this lock right here on the bearing? You always put the lock to the lock. Here's another really important thing. Notice how there is an O-ring in the block right here where the oil pressure comes through the cap from the pump. And you gotta get this on around that rear main seal. Now we can lightly buzz all those down and then torque them.
One thing you always want to do is set the thrust bearing. Now the thrust bearing in the big block Chevy's in the back, so I backed off those rear main cap fasteners and I ran them down just snug. Now to set it, I'm just gonna give it a sharp wrap at the front of the crank. And then I'm going to go to the back. I'm going to do the same thing. That should bring both the halves of the bearing shell in alignment. And then I'll retorque it, measure the clearance with a dial indicator in the front, and that's all there is to it. I've got the dial indicator rigged to the nose of the crankshaft, and I've got it zeroed. The only thing you have to do from there is lever the crank forward and back, and I've got 5.5 thousandths end play. That's perfect.
Just like we had to check the bearing clearance on the mains of the crankshaft, we also did it with the rods. Basically, we've installed a bearing and torqued the cap on here, and then we've set our standard based on the size of the crank journal. And now Steve's using the dial bore gauge to go in there and find out what the clearance is, and we already know that it's about 2.8 thousandths on each one, which is exactly perfect. So we're good to go. Next thing, we have to slam the rings on the pistons and then put the short block together. Here's something I wanted to show you about connecting rod bearings. You'll notice on aftermarket crankshafts, there are fillets or a radius right here at the cheek of each side of the journal where it rolls up into the counterweight. Now, the thing about those is that you do need narrowed bearings like this. This is a Clevite bearing, and if you see N in the part number, it means that it's been narrowed. See how it doesn't quite reach the end of the cap right here? And because of that, these are marked upper and lower. The upper goes into the rod, the lower goes into the cap. You can see that that bearing goes right there and fits up against that radius without interfering with anything. If I take this bearing that goes all the way out to the side and shove it up against this radius, I can actually feel that it's dragging in there, and that will spin a bearing if you don't get those on the right way. So make sure you get that right.
Much like we check the clearance in the bearings, we also check the piston to wall clearance. Now, to do that, I used a micrometer to measure the piston skirt, and then we use that to set the dial bore gauge. And now, the last step is just going to be taking a measurement here of the clearance, and I've got 4.7 thousandths clearance. That's really good for a blown motor with a forged piston. I'm going to go ahead and check all the rest of them. If they all turn out the same, I'm a happy guy.
We're all ready to install pistons. I can't believe that I have not revealed until now that our block is now bored to 4.32 inches. Combined with our 4¼ inch stroke, the crusher engine is now 498 cubic inches, which is awesome. So this tool that I've got here is a tapered piston ring compressor. You just set it on the block right there, and then you slip your piston in with your rings all oiled up and nice. And all you have to do is smack those in there. So I get it right about there, and then whack, all in. Perfect. So the pistons that we're using here are from SRP. They're the shelf line from JE pistons. They're a forging, they're flat top. I think this engine is right at 9:1 compression. And check out how the connecting rod is just the very, very basic stuff that you get from Scat. We should probably be using a better rod in a supercharged engine and something better than a cast crankshaft, but we're not, and it's lasted this long, so we're probably all good. I do trust this piston though. Here's where I'm going to shaft myself. I've always said that I like the crusher engine combination exactly like it is, but I couldn't stop myself from a little bit of bigger, badder, faster, louder, and so the camshaft is going to change a bit. I decided to go with a Comp Cam's blower cam. This one has 230 on the intake, so really the RPM range of the engine should be about the same, even though the lobe separation angle is wider, so that might push it up in the RPM a little bit. But the big deal is that the exhaust duration is 242, which a blower engine tends to prefer. So I hope this doesn't really change the overall characteristics of the engine, but makes just a speck more power.
Boom! That camshaft spins in the block like butter.
L&R Machine put the cam bearings in for me, which was like huge. Also, this is a cast core camshaft. Sometimes rollers are a billet core, usually not hydraulic rollers, but that means we can use a conventional distributor gear on it. Okay, Steve sort of roughly checked to make sure the cam timing is good enough. Now we've got the cam on the block and the timing chain and everything. He's even got this locked down. See this white plastic thing right here? That is called a thrust button, or sometimes just a cam button. Because this is a roller cam rather than a flat tappet, it needs to have an end play adjustment. So we've got that button right there, which is going to hit that mark right there on the inside of the timing cover. I've got my gasket in place. I'm going to throw the cover on, and if Steve gives me hardware, I will bolt it down, and then we will use a screwdriver to walk the camshaft back and forth to make sure that it has enough end play. Okay, ready to flip it over and install the oil pan? These one-piece gaskets with the steel core, the greatest. Okay, Steve, I'm liking it. Ready for pan. All right, moving on to the next thing that we're going to do completely wrong, which is using a regular old damper on this engine. Usually for a Roots supercharged application, I order a custom crankshaft that has 2 keyways, a quarter on one side and a 3/16, 180 degrees out, and that keeps the damper from actually falling off because there's so much more load on it when it's driving the supercharger. But we didn't do that. We're going to just slam a regular old damper onto our cast crank here. Here's another area where I couldn't leave well enough alone, the cylinder heads. So the original heads on the Crusher engine were these Holley Systemax oval ports, but as you can see, they got really rusty in the disaster with this engine. And so my options were send them out to a machine shop, get them all valve job, get them fixed, or get new ones. Here's why I chose to get new ones. You can see by looking at these that they're what's called an oval port design. The problem is the manifolds for Roots superchargers are all, as far as I know, rectangle port designs. So the port in the intake manifold is as big as this rectangle. You can see it's way smaller than that. Look at that. There's a port mismatch by that much. And it's in the direction of airflow. And so it is just a disaster. So I wanted to switch up to a rectangle port. Here's what I chose. This is a Brodix Race Right head. It's their budget line that uses all stock components. This is a 294cc rectangle port head. So really a small head for a 500 cubic inch engine, or 498. But they were affordable, and that's what I got. But let me show you the other reason that I chose them as I turn both of these cylinder heads around to the exhaust side. So one of the things that is very common on aftermarket cylinder heads, not just for big block Chevys, but for all sorts of engines, is to raise the exhaust port. They will actually take the whole port and lift it up by about ½ an inch to improve exhaust flow. The problem is that tends to give a lot of problems with header clearance and things like that, and I knew that the Systemax heads did not have a raised port because they were designed as a stock replacement part. The Brodix Race Right also does not have a raised port. So that's why I picked it, hopefully giving me no difficulty in installing it in the car. The only potential pitfall could be if the rocker stand height is different from head to head and if I end up having to have different push rod length. We'll see. It's an exciting moment when you get to install cylinder heads. Feels like you're accomplishing something. So one of the things that you need to pay attention to when you're working with these big block Chevys is that if you've got a Gen 5 or 6 block, like I do right here, a Gen 5, it doesn't always work with head gaskets off the older Mark IV blocks. They've got these water passages in different places, and honestly, I don't know the exact details, but I know it can be a disaster. There are gaskets that are specified that will work for putting Mark IV heads onto Gen 5 and 6 blocks. Here's another thing about installing heads. You gotta have these dowels in place, which on a big block Chevy are like these whole circular spacer looking things, because those actually locate the head and the gasket, and then the head bolts only clamp them down. Speaking of head bolts, one thing you have to really pay attention to when you're getting aftermarket heads for any engine is that they often take bolts that are non-stock length. Usually the manufacturer will list a specific ARP bolt manufacturer part number to use their head, and so I've gotten a set of bolts here, and I think it'll be okay. So I'm ready to bolt this Brodix head on. There we go. Okay, I double checked the torque on every bolt here, making sure everything is seated and good, which they are. So the cylinder heads are officially on. Next up, I'm gonna start installing lifters. And actually, there are some engines where you cannot get a tall hydraulic roller lifter into the block with the cylinder head installed. But in this case, it is no problem whatsoever. So I'm gonna inspect every roller, clean them up, lube them, install them. Then we'll move on to push rods, rocker arms, poly locks, and only then we have the glorious blower intake manifold. It appears that we got away with the push rod length. I think it's going to be okay even though we changed the cylinder head. Sometimes that doesn't happen if the pad height for the rocker stud is different from head to head.
You dodged a bullet again, Freiberger.
I know. So coming up next, push rod guide plate adjustments.
Here's a little tip when you're setting up your valve train. You've got to ensure that you've got good alignment from the roller on the rocker arm to the tip of the valve. There's a little bit of wiggle room in the guide plate, but that wiggle has to be pretty much centered on the valve tip. Now, the rocker stud actually captures the guide plate, and if you slack it off, you can adjust the guide plate side to side, and you want to see that alignment as close as you can get. It's pretty much centered there, and then you just lock it down, just like that, and that is adjusted to my satisfaction.
This is a hydraulic cam, so we're preloading all of the lifters right now. We're giving them all half a turn of preload, plus another eighth, which is the locking technique. The polylock here has an Allen set screw in the middle of it, and a 5/8 wrench on an outside shell. So you'll see Steve is going to hold the lock nut and then twist the whole thing and lock it down. Time to test fit our wind supercharger intake manifold. Hopefully the port alignment is way better than it was with those oval port heads, and the end gaps are good. Ooh, they're pretty tall. Gonna need a lot of silicone right there, maybe even a cork. How's the port alignment though? Oh wow, way better. This is gonna make more power. Faux show. This goes wrong, it's gonna be a mess. We might lose the shop. Okay, here we go. You gotta get the plonk perfectly in line with the bolt holes and perfectly flat. And there we go. Oh, that was a pretty nice plonk, Steve. Oh, look at that.
Oh, that is
Mint.
perfect. Wow, Freiburger.
Yeah. Boom. We've gone as far as we can go with our engine. It is like as built as it's gonna get before we plop it in the car. So now I'm shoving this out of the way, and we're gonna move on to working on the engine compartment of the Crusher Impala.
This thing weighs a ton.
Next thing I'm gonna do is start cleaning up the engine compartment. I've got no aspirations for like painting it and making it show quality and stuff. However, I hate the messiness of it. I need to get rid of the whole air conditioning box. I would like to neaten the wiring. I'm not sure I'm gonna have time to completely dial that in. Steve, did you want to save this AC? Like use it in your Pontiac or something?
I considered it, but my
Really?
Pontiac already has it. Oh, dude, are you kidding me?
What? I wanted to save you the trouble of having that sitting around for a decade.
Dude,
I feel
those are
destructive right now.
super rare Chevy vintage air conditioning parts.
Give me the Sawzall. Normally I don't like ruining things for no reason, but I had to save Steve from himself because he would have spent 3 hours carefully removing this, and then it would have sat outside in his backyard for 30 years while he considered installing it in his Pontiac. Okay.
It's like archaeology.
Is this the condenser?
No, that's the evaporator.
Evaporator, right?
Okay, Freiburger, that's the trick. You just pull it out vertically.
I have no expectation of getting new upholstery that matches the car at all, but it doesn't matter. Thing's disgusting. Aha! I'm changing up my ignition situation. You see, adjusting your timing curve is really critical when you've got boost because you got to keep the engine out of detonation to make it survive. We've been doing that on the Crusher Impala with this MSD programmable box. This thing was even on the Crusher Camaro. The problem is this takes a PC computer to plug in and map out your timing curve, and it was wired really butch. I've lost the computer. I don't want to deal with it, so that one is going away. Instead, I am installing the MSD 6 BTM Boost Timing Master. Now this thing comes with a knob like this that you may recognize from such roadkill vehicles as the Rotson, the Jaguar, the Thunderbird. What this does is it sets the number of degrees of timing retard per pound of boost. So if I have it set at 1, that means it retards the timing 1 degree for every 1 PSI of boost. I'll probably set it at 1, and what that means is if this thing makes 5 to 7 pounds of boost, and I've got my timing set at 35, then at wide open throttle under boost, it's gonna retard it to 28 to 30, depending on where I've got it set, which is gonna be just about right. It's just a way simpler way of doing it versus the computer controlled unit. And I'm gonna be able to hide this baby to go inside the firewall, right like this. All right, we're gonna mate this engine to this transmission and drop that junk in the car. Coming down. Okay, stop. Lower it right there. Stop. Okay, we have to sort out the headers now. Okay.
There you go.
Okay, down slow. Stop.
Woo!
2 9x4 threads. It is time to pre-lube. I got the special tool, goes down, engages with the oil pump drive shaft. We're gonna spin it till this thing has oil pressure and I see oil coming up out of the rocker arms right here. And only then will we know that the engine is safe to continue to keep assembling. Oh, it already got pressure. We're good to go. Keep assembling this thing. I'm going to install the distributor. You remember how rusted the old one was all over the reluctor? I got to be honest, if you were really on a budget, you could have taken that apart and cleaned it up, but I'm really in a hurry, so we didn't. We bought this new MSD unit, which is trick only because it is factory black, which I like because I'm trying to like downplay the bling on this thing so you can focus on the valve covers that you will soon see, those gold Morosos, and of course, the supercharger. Boom, lock her down. All right, kids, you know what time it is? It's blower time! Woo-hoo! Yeah! I'm super stoked on my blower. This one had been blueprinted by the blower shop and it had Teflon strips in it, and the Teflon strips wear out after a while. That's now a filthy disaster. This thing is an out-of-the-box YN supercharger. It's got no Teflon strips in it at all, so there's nothing to wear out. Unfortunately, it's not as efficient. You have to spin it harder to make more boost, and that's okay, because I'm only looking at making like 5 pounds. But this thing is ready to go with its pair of Holley 950 carburetors and its Street Machine polished goodness. I love my 871. I love it so. Let's install this thing. Okay, hold on.
Wait, I can't see my bolt. I'm right on it there.
Yep.
Woo. Yeah, that wasn't too bad at all.
Not at all.
Okay, Freiburger, we've just grown up a whole bunch.
Great. Now I'm going belt. Blower's not a blower until it has a belt. Did you know most of that cool whining noise is from the belt? I'm gonna tighten it roughly there, and you wanna be able to turn that belt just about that much. Next on our list is to drain all of the old gasoline out of the tank. It's been sitting for like, I don't know, 2 years or something like that, and I just don't want to run old dead gas on the blower engine. So, ready for me to turn on the fuel pump?
Sure. I don't see any gas coming out this end.
It's not running.
Okay.
Let me turn on the ignition. Fan works. Fuel pump not working.
I don't hear any relay clicking.
Yeah, everything else is working. I think I screwed up the relay to the electric fuel pump. Yeah, all the gauges and everything light up in here, but the fuel pump's dead.
Is that the relay that's up here by the firewall?
It is.
You can feel it. It's working.
It is?
Turn it off. Yeah.
Really?
On. Yeah.
What we're working on doing here is just jumping a wire directly from the battery to the feed line to the fuel pump so we can find out if the pump works. Go on. Fuel pump's not working.
It is dead as a doornail.
I'm gonna have to get under the car and find out what's wrong with the fuel pump and chase this wire. Maybe I hooked it to the wrong wire. Hey, Steve.
Yeah.
It is an intake fuel pump. I need the test light. Oh, yeah, I got power back here. Shoot. I was really hoping we had no power because that would mean it's a wiring problem, not a fuel pump problem.
How hard is it to take out?
Normal, 2 straps.
Oh, you mean we have to take the tank out?
Yeah.
There is no fuel in this at all.
No. So here's the thing. The last time we saw this car, it was running perfectly, but because it's got all kinds of weird switches and stuff, people ended up leaving the fuel pump running all the time. I used to have the fuel pump hooked up through the headlight switch. Remember that?
Oh, yeah.
Yeah, and so because of that, I'm sure this thing was left running and it is all melted out. So we have no choice but to get a new one.
So the fuel pump was burned out. That kind of slowed us down a little bit, but I've got the new one in there. It's all wired up and plumbed, and the only thing left to do, really, is pour some gas in here and hope the tank doesn't leak.
So just turn on your fancy schmancy fuel pump.
I'm a little afraid. What if the car explodes when I flick the switch?
There we go. I hear the pump. I hear it picking up fuel.
I hear it loading up.
It's delivering fuel. You gonna try and start it?
Sure.
No spark, right?
Seems like there's no spark.
That battery sounds dead, though. Less than 9 volts in MSD usually won't fire. Let's check this. It's 11.9 and crank it. 10.5. Let me look at the MSD box, see if it lights up. It's got power to the box. Is the distributor plugged in?
I don't know, I was gonna check. No!
What?
Rats.
Oh, you're kidding.
They ate through the connector. Look.
Oh, and they had to chew them like right up close to it where you can barely get a connector on it.
Oh, it's gonna be a butcher repair at this point.
That's stupid.
I'm physically ill over these rats. I need a cat. That would fix it.
There we go. That's what I like. New engine come to life. After all of that work, 498 cubic inches, rectangle port heads, slightly different camshaft, blower that hopefully works, and as you can see, we removed the scoop and installed a couple of air cleaners just because the scoop's a pain in the neck. And I never thought it looked quite right on this car. I actually like these better. I'm sure the viewers will disagree, but it won't matter when you see the burnouts that we're about to execute. Vital signs look good. Oil pressure. Ooh.
So far, so good, yeah.
Water temperature is 200. Is it coming down?
Did you have the fan on?
Yeah, fan's on.
It's 190.
Yeah, it's coming down. This is our best riding car on this road by a lot.
Oh, I know, the B-body Chevy is just the best.
Not to mention the added weight of the blower just adds to the ride quality.
Oh, it does.
Wonder if it does rolling burnout still.
Are you in first gear now?
Oh, it is.
It is first. I think first gear would be pretty useless.
Yeah. Wow!
Don't hit a pole.
That's third gear. You can't.
Wow, that was third gear?
That was third gear.
I was too busy looking at the pole to realize what,
I was looking at the gauge, and
Yeah?
I was like steering. Then I glanced out. I realized I need to be driving this thing still. Wow.
it's got massive amounts of torque for some reason.
For some reason.
Do you think it'll burn them off from a dig?
From a dig?
Yeah.
From a dig means from a stop.
Yeah, I know what a dig is.
Pretty sure it will. Oh, man. That is the greatest burnout machine known to man.
That is scary from here.
I'm sure that was terrifying from the passenger seat.
Oh, it was, yeah.
Because it just wags. It's because the road is
Well, I
crowded.
saw that huge haystack.
Yeah.
I was like, man, that straw is like hitting a brick wall.
I figured if I aimed for the haystack, I would miss it.
You did.
Yeah. Okay, I think we're drag strip ready. How about you?
This car has ludicrous power.
Here we go, Auto Club Formosa Raceway, quarter mile.
All right, Freiburger did a great job on the line, getting some heat in the tires. We've got over 2 tons of Chevy here, but we've got a ton of horsepower. This is all gonna happen on the starting line.
Fuel at the top end. Unbelievable. Man, it was hauling off the line. It hooked hard. I don't think this fuel pump can keep up, or we don't have enough gas in the tank. Oh, that is the worst.
The fuel pump. We talked about it. I was like, man, I don't know if you've got enough pump.
Once again, snatching defeat from the jaws of victory here on Roadkill Garage. That could have been amazing. Ah! Well, there's no way that's going to get any better. It's out of fuel.
Yeah, we were talking about that earlier.
Unfortunately, it only went 12:26 at 97 miles an hour because it ran out of fuel, I would say, before the 1,000 foot.
Yeah, I could hear it. Well, we could put more gas in the tank.
Let's throw more gas in it. Like, we have to do that super quick. Okay, here we go. This is my last shot. We've got the tank full of gas. If this doesn't work, nothing will.
All right, that was a pretty good burnout. That's what we needed to get some heat in the tires because we'll probably only have one shot at this. Now, this thing does a pretty violent launch. I'm going to be checking out that front tire.
What does it say? Slow, 12:10, 110 miles an hour. Ah! Here's the best possible news. It went 12:10 at 110 miles an hour, and it doesn't even have secondaries on the carburetor. We are not at wide open throttle. Cleet here at the track asked the question. Steve walked up and checked it, and sure enough, it's a mess. So Steve's fixing it, and if we've actually got time to make this happen before it gets too hot, this thing is going to be fast with a capital F. Here we go. Should be faster than ever.
Okay, we're lining up for another pass, and this time we actually have a hope of a better time. We adjusted the throttle linkage. He's rolling into the beans, and this may be the best yet.
Woo! Okay, that was way faster, but it was a mess. Man, this thing wants to rev now that it's got throttle and boost. Wow, that was 14 pounds of boost. That is crazy. I cannot wait to get back to the track on a day when we can actually take the time to refine this thing. Oh, man, that was a mess, but I'm excited, dude.
Wow.
This thing makes power now.
No, if you can tame this beast, you can knock a ton of ET. That was like raw as raw steak, man.
I know. We're making so much power now that the whole rest of the car is a disaster.
Right.
Like, I wasn't on top of the shifts. It spins the tires really bad. Spun the tires at half track. Was on the rev limiter, like, right as I hit the lights.
Couldn't have made more mistakes on that pass.
I know.
What could you do? And plus, it's still only getting 3/4 throttle.
Yeah, I know. That's still the quickest pass it's ever made. 1175, biggest mile an hour, 118. I don't know. I think it's a disaster now, but it's got more potential than ever. This thing is actually going to be fast when we sort it out. That's why I say I'm excited. It's like it's a fail, but it's a roadkill win, and it's got all sorts of potential for upside without having to completely rebuild the whole car.
No,
we just got to deal with throttle linkage, some valve covers that don't puke oil on the headers, figure out how to actually make it hook instead of relying on 50-year-old stock suspension.
Right.
Dude, I'm pumped.
Oh, yeah. We're making horsepower, bro.
Dude, boom! That is a win on Roadkill Garage, man. If we get this thing fixed, you will see it again on Roadkill Garage.
If you were in Australia, you would note that rather than the counterclockwise swirl, it would swirl in the opposite direction. That would be clockwise, because the magnetic polarity south of the equator is the opposite of north of the equator. If I reverse the tangency of the pore, I'm on vacation in Australia right now.